In today's digital world, billions of URLs are shared every second, but not all of them are safe. Cyber attackers often use malicious URLs to steal personal information, inject malware, or launch phishing attacks. By analyzing URL structures, IP patterns, and network behavior, we can accurately differentiate between legitimate and malicious URLs in real time.
Cyber attacks are becoming headline news almost every week, showing how urgent and critical cybersecurity has become in today's digital era. We are Team IP Shielders and we are excited to present our innovative solution at the Smart India Hackathon 2025. The problem statement focuses on the identification of URL based attacks from IP data. The statement is provided by the prestigious organization National Technical Research Organization, and this problem falls under the category blockchain and cybersecurity. Our project title URL Threat Monitor. The problem statement description is cyber attacks through the HTTP URLs are rising fast using methods like SQL injection, XSS, and SSRF make challenging detection. Current systems fail to clearly separate this type of attacks from real breaches. So, we aim to build a scalable automated solution to detect, classify, and visualize such attacks. The main features our system offers is detecting different types of URL based attacks and separating attack items from successful attacks and using datasets and external PCAP files for analysis and providing a simple GUI for results and queries. And finally, exporting results in CSV and JSON formats. And also, it supports adding new features.
Our approach to this problem focuses on detection, classification, and analyzing URL based attacks in real time. In first attack detection engine, we detect multiple URL based attacks like SQL injection, XSS, and SSRF by using simulated data sets from tools like SQL Map Burp Suite to monitor HTTP traffic for malicious patterns. And then we classify and categorize different types of malicious URL based activities such as phishing, malware distribution, and then spam. And next, data integration. We support large self-generated datasets and ingest PCAP files to store results in structure format for any queries. And visualize attacks by type and status, provide real-time search and filtering option by interactive dashboard showing graphs, charts, and attack timelines. And finally, we export results in CSV and JSON formats and generate attack summary reports and share logs for any further analysis. This is the graphical interface that we design for users to interact to check whether the URL is safe or unsafe. Here we can see what is a malicious URL and how to check whether a URL is safe. Here are three steps to check. The first step is to enter the link and wait for a few moments and finally see the results for whether the URL is safe or malicious. Why should you choose CyberGuard? It works on multiple platforms, has massive data sets, and works with machine learning, and it's completely free for everyone. Here in the dashboard section, we can insert PCAP file, which is a file format that records and stores network traffic data packets for analysis. We have to choose the file, and here the selected file is Wireshark, and we have to click on process file. And in the URL analysis section, we can paste any kind of URL and click on scam. Here we can see that URL detected is malicious and the type of URL attack is directed traversal. Let's paste a safe URL and see what it does. Here we pasted a google.com, which is a safe URL. We can see that here it shows as URL is safe. In the export results section, we can export results either in CSV and JSON format, which will be in a columnar structure with the IP data, IP range, and timestamp. In the attack analytics section, we have total number of attack occurred, successful attacks, and the success rate of attacks. Here also shows a graph of multiple type of attack occurs at which rate. And here also a attack over time graph with the timestamp. And in the attack details section, we can see different types of attacks like typo squatting and URL spoofing, SQL injection, cross-site scripting, directory traversal, command injection, server-side request forgery, local or remote file inclusion, credential stuffing brute force, HTTP parameter pollution, XML external entity injection, and web shell updates. And in the attack logs section, we can see timestamp, IP source, attack type, URL exploit, and status of the attack occurred. Here we can also filter attack types. I have chosen cross-site scripting and we can see the status of the cross-site scripting attacks occurred. We can see one attack of cross-site scripting has occurred. We can also filter attack types with status let's choose the status of successful attacks. Here we can see successful attacks are 1, and we can also filter by using IP. Here I have entered the IP address and filter the attacks with IP address. With this IP address, let's see how many type of attacks are occurred. Here we can see that 2 attacks occurred with the same IP address.